Here's another device that followed me home from a Hamfest a while back. This is a Yaesu UHF repeater. It's a model FTR5410, and they made different models of this. This is an older unit. These are probably 30, 40 years old at least. I'll have to look up the specs on it. These were made in VHF and UHF. Like I say, this is a UHF model, and this is a Type C, which covers 430 to 450 megahertz. And the transmitter output's 10 watts, and the receiver sensitivity is supposed to be half a microvolt for 12 dB SINAD, so we'll see when we put it on the monitor. This unit has been modified. There's been some modifications that I'll have to check. I do have a manual for it, so we'll see how it goes. I haven't powered this up yet. Supposedly it kind of worked, the guy said, but I'm not really sure of the condition until we try it here. So stand by. Like I say, this unit has been modified. On the back there's a number of RCA jacks that have been added, which are not in the manual. So we'll have to check and see where they go. So I guess the next step is to open the hood and see what we find inside. Hopefully no bad surprises. Here's a view looking in the top of the unit here. And as we saw in the back, there was some modifications done. Here's the back of these RCA jacks. I don't know where they're going. We'll have to sort that out. This wire's been cut. Not sure where that goes. Anyway, this is a relay switching unit. Here's a power supply. The transmitter's under here. Receiver under here. And of course, this is a main power transformer here. Unit looks pretty clean inside. I don't see anything that looks like it's damaged. Anyway, we won't know till we power it up, will we? Here's a look inside of the transmitter section. Pretty straightforward. It looks like here's the exciter section, and then it drives a power module here in the output here. The output, like I say, is 10 watts. Comes out through the antenna jack here. You can, the transmit out is on the side here, and the receiver output is on the side here, and they're isolated by distance. Plus there's pretty good shielding in here. Here's the receiver section. You can see where the RF comes in through this coax cable, and then it comes through these resonators here, and then into the receive circuitry here. And next we'll look in the bottom of the unit, which has the control section that takes care of things like carrier operated relay and DTMF. I don't know if it has a DTMF board in it or not. It comes with a delay timer also, as standard, a timeout timer and a delay timer, delay drop I guess you'd call it. So we'll look into that a little bit later. Here's some masking tape. Well, that's not a good sign. Here's the transmit crystal here, and likewise here's the receive crystal here. And looking at the block diagram, you can see that the transmit crystal is multiplied, goes through multipliers times 12 to reach the output frequency, and the receive oscillator frequency or crystal is multiplied by 9, and it's put into the first mixer here. It's a dual conversion. Here's a view of the bottom of the unit. This is the COR board, the carrier operated relay and control board here. There's no other options. There could have been a DTMF board which would have been located here, and it had an option also for a CW which could have been installed in here also, but that's okay. I've got some boards I can use for that, especially the DTMF. I want to be able to use that, and I have an outboard CW identifier. I think Communication Specialist or somebody made it. It's a small rack that can be installed in this, external to this, but it can supply a CWID that I can program with my own call sign in it. Here's where the transmit here comes in, goes up to the top of the transceiver. Here's the receive section, comes in into the receive section under here. Bridge rectifier here for the power supply. Here's some filtering where the line comes in, which is good. Wrong kind of capacitors though, they can be replaced. And other than that, hopefully this is the important part here, the COR board, which controls pretty much everything. It's got the timeout timer, the delay timer, controls the switch between transmit and receive, etc. So we'll see how that works. It looks like there might have been some modifications on this also. I don't know if it's factory or if it was by the user before me, but we'll find that out. So the next step, I guess, will be to hook this up to a dummy load and a power supply and see what we get. Okay, I have a dummy load connected and got the unit plugged in, so I'm going to give it some power. I'm not going to put it on a dim bulb. I didn't see any burnt or abused components, so we'll take our chances here. Anyway, here's the power switch. See what we get. Oh, that's not good. Well, the power light comes on. Squelch works. Transmit came on. When the squelch opens, the transmit should transmit, which it does, and there's a slight delay. Should transmit off. Okay, yeah, we got a hum in here that's on all the time, so sounds like a power supply problem. Maybe the main filter cap. Got a regulator board here. We'll see what happens. I think what I'll do next, I'm going to try powering it on DC and see if I still get this bad hum, and that might rule out our power supply, our AC supply here. I connected a DC supply, external DC supply, and disconnected the AC, of course. So I'm going to bypass the AC supply, and let's see if we still have that bad hum. No, we don't. So let's open the squelch. Okay, yeah, it's a power supply problem. I'm going to open the squelch. Let's see if we get any transmit power out here. And the transmitter is putting out some power, a little bit low. Here's measuring with a scope across the output of the main filter cap. I'm getting about 200 millivolts. Let's see, 2, 4, 6, 8 milliseconds. That's 100, a little over 100 cycles, 120 cycles. So that's a full wave rectified. But look at the level of ripple here. That seems high a little bit. So let's see, times one probe, 50 milliseconds per centimeter. Yeah, about 200 millivolts, and I'm measuring right here on the main filter cap. Okay, this is measured on the collector of these two transistors. These are two SC2987s, and they're in parallel, except they've got two low value emitter resistors to balance the current, and then they feed let's see, they feed input of this regulator. Okay, now I am measuring where the two ballasting resistors, emitter ballast resistors, are connected together here, which would be this point here. And I'm getting about 0.2 millivolts of ripple. But we sure have a terrible hum here. I wonder if some of these modifications, I might have something hanging open here that's causing this trouble. I don't know. We'll have to dig into this a little bit further here. All the modifications have been removed. I had a number of RCA jacks on the back here, and I've got to do some rewiring. This is a push-to-talk line that isn't connected, but as you can see, the hum is gone. I must have had a ground loop or something. There was wires running all over the place in here, and I'm not really sure what, but I noted all of the mods that were done, and they're all been removed. So now I need to reconnect the push-to-talk line, figure out where it goes. It's this wire right here that comes off of the COR board, and once that's connected, hopefully, then I have to reconnect the accessory jack. I've got a bunch of shielded cables here that go. I got to figure out where they go. But anyway, the good news is the bad hum is gone. Must have been some kind of a ground loop. Well, it appears there's a problem on the COR board here. Okay, when I put the function switch, the mic repeat switch in repeat, the transmitter keys automatically with no input. When I go back to mic, it stops. Transmit lights on, the busy lights off. For some reason, the transmitter is remaining keyed with no input. Well, the repeater's repaired. Found a few problems. I removed all of the modifications that the previous owner did. He obviously had this part of a system and had a bunch of other devices hooked up to it. I removed all of those, but I still had the problem. The problem was when the mic repeat switch was in the repeat position, the unit would key without any input. And what I found was Q09 here, which is it's a quad 2-input NOR gate. This chip was bad, so I removed that. I put a socket in so I could replace it if I had to. I always do that. If I have to remove a chip on these double-sided boards, I always put in a socket, because you can only remove these components so many times before you start lifting traces, which I did have a little problem with this. I had to put a jumper on one of the traces between pins 2 and 4, came apart on here, so I repaired those under the board. You can go on the internet and find a manual for this repeater. This is a chip that was bad, Q09, quad 2 input NOR gate. Other than that, it seems to be working all right. In the mic position, you can talk through this unit as a regular transceiver. In the repeats position, it is an actual repeater. So now I will transmit in, and the output's coming out on this old Radio Shack HTX 404, and you can see I'm getting output now. Test 1 2, test 1 2. You can see the delay there, the delay drop. That's adjustable. You can delay the timeout timer, and you can adjust the delay drop timer, which are done with dip switches here on the COR board. This is pretty much the brain of the unit. Transmitter and receiver on the underside. You can add a DTMF option here that plugs into this connector. I'm going to add a DTMF board I'm going to build, so I'll utilize this connector here. Other than that, the thing's working good now. I rewired the accessory jack. There were a bunch of RCA jacks on the back that they had gone in and monitored certain functions on the unit here. I think what happened, there was some wires added to this chip that were soldered on the pins that went to a terminal, and I'm wondering if maybe some static charges took the chip out. I don't know. Anyway, the unit's working now. All I need to do now is find my set of duplexers I have out in the boneyard, and then this unit should be okay. I probably will have to get new crystals for it. Uses 2 crystals, one for the transmit, one for the receive. And after that, we'll have a nice UHF repeater up here on the ridge. Anyway, that's it for this project. Thanks for watching, and see you next time.